The Tutorial and Tracks Committee has started up a number of tutorials which are going to be done. This is Intro to ipv6. The target audience, that's you. Are you comfortable with IPv4? Are you comfortable with CIDR notation? If yes, you're in the right place. Clicker's a little bit slow. No, you might get lost. Quick show of hands, is everybody here savvy IPv4? Okay, good. Is anybody here a real IPv6 professional who brought tomatoes to throw at me? Darn. Okay, so not really an agenda, but where we're going. A bit of the timeline, concepts, whatever. IPv4 historically is probably the most used protocol. It's actually impossible to measure how much IPv4 is out there simply because so much of it's hidden behind NAT, which is in and of itself an evil thing. Big concept that we're going to touch on is the fact that IPv4 addresses are integers. That's right. It's a 32-bit number. You can just type SSH 47 and actually connect to something as long as there's something at 47 to connect to, right? Good. Normally you display them as quad. 255, everybody happy? Yeah. So, what is v6 and what isn't it? It's new, it's next generation, it's wonderful. And it's notes on my laptop because I couldn't print them out. First real old, 22 years out there, first public blocks, amazingly, 1999. Designed with security in mind, implemented in hardware, it's just as fast, if not faster than v4, which is a truly cool thing. It's extensible. The extensible headers in IPv6 are how you get SRv6 to work. Is anybody in here a segment routing person? Okay, one segment routing person. So basically with segment routing, v6, you stuff all of your extra address information on your path into a segment header and out it goes. And there are several migration aids. You can encapsulate IPv6 datagrams in IPv4 to traverse them over an IPv4 network. That's tunneling. Everybody's familiar with the concept of tunneling, I hope. Next room over. So, IPv6 has one real strike going against it at this point, and that's people just don't know about it yet. But it's got many things going for it. And the big thing that's going for IPv6, well, there's this little problem with population. If you look at the population of the Earth, it's about 3.5 billion people at this point, give or take a bit. Yesterday, somebody was saying there were 4 billion internet users. I believe it. The only problem is if you actually do all the math and subtract out all the bogons and everything else, there's only about 3 billion usable IPv4 addresses. So the biggest feature is space. There's a lot of it. Okay. Everybody has a metaphor. This is mine. Some people use the grains of sand on a beach, the number of stars, whatever. You can work it out. But it's a 128-bit long number, which is really kind of hard to do as a decimal. And it's big. 3.4 times 10 to the 38th undecillion. It's a number you just can't wrap your head around, it's so big. But right now, we've only allocated a very small fraction of it. It's still about 2 to the 125th available spaces after what's been allocated. So, formatting. Everybody here is familiar with IPv4 addressing. IPv6 addresses are a little bit of a different layout. They're much longer. You never have to type an IPv6 address unless you're doing manual configuration, hopefully. That's what DNS is all about. Everybody here do dual stack DNS? Anybody do dual stack DNS? Okay. That's okay because either IPv4 or IPv6 DNS can resolve either IPv4 or IPv6 addresses. Really nifty that. All addresses are represented as 8 groups of hex digits. There's a long number. Quick show of hands. Is that a number that you want to read or work with? Hands up for yes. Hands up for no. Oh, good. Everybody's sane. And CIDR notation. Everybody's comfortable with CIDR notation? Okay. So, IPv6 address.gzip. Anyone? Okay, so you're all familiar with what a moose is? Moose? Moose.gzip? Okay. Some of these are going to be good. So, in readability, all alphas in a v6 address are lowercased by definition. This is actually defined in RFC number something, ask me later, or download the presentation, all the notes are in it. And you're probably going to want to download it because there's some charts in here that if you take pictures of them, they're not going to look very good, but they'll be great in the PowerPoint. There are lots of zeros. We can get rid of them, and there are rules about getting rid of them. Leading zeros in a block that only can be suppressed, they must be suppressed. You can just read it, but basically the bottom line is you can take a lot of zeros and using a token of 2 colons, get rid of them. By convention, you are supposed to get rid of as many zeros as you can. If, perchance, there are 2 blocks of the same number of zeros in an IPv6 address, you compress the first one, and you always get rid of leading zeros. So that is what it comes up to when you're done. Is that an address you can deal with? Okay, so it's not that bad. There are footnotes, you'll get that later. Sometimes, as a migration aid, you may want to embed an IPv4 address inside an IPv6 address. It's defined in RFC. You can do it. I give you IPv4. IPv6, same thing. Very often used by people who are adding IPv6 to an existing IPv4 backbone and for whatever reason don't want to do a proper IPv6 address matrix. Or if you want to use the IPv4 address as an index, you can do it. The compressed ::ff is used for v4 or v6 routing. You'll see that fairly often. So, 3 types of IPv6 addresses. Unicast? You're unicast. Anycast. Different nodes goes to the topologically nearest address. So if you, and you are an anycast, and I send something to anycast, it'll get to the first anycast node, which would be you. Yeah, real simple, right? Multicast, groups of addresses. They'll belong to different nodes, but you could have multicast addresses, multiple multicast addresses on one physical interface that get addressed as parts of separate groups. Traffic is sent to all nodes in a multicast group that are accessible, as opposed to anycast, which will just be the topologically closest. Sort of like that MacBook person in the 3rd row. Okay, curveball time. Has to be a sports reference, okay? No broadcast. Would everybody like to get rid of broadcast storms? Okay, get rid of v4. No v4, no broadcast, no broadcast, no broadcast norms. Is that not a good enough reason just to move to v6 by itself? Okay, so no broadcast means no ARP, and we'll touch on how that's done later. But there is no ARP, but there is a way to map from a MAC address, which still exists, to ipv6. Okay. Quick reference. Sorry, my laptop walked up on me. This is a quick reference chart. Don't bother taking pictures of it. You can download it. I don't even think I stole this from anybody. So, unspecified, loopback, IPv4 mapped, multicast. You can tell what a multicast is by the prefix. Neat, isn't it? By definition, we know that that's a multicast address. Link local, which we'll get to, also defined. Unique local address. Think of a unique local address as RFC 1918 address space. Kinda, sorta. One of the neat things about v6 is that you can have many unicast addresses on one interface, and based on routing, you will go in or out of the same thing. So you can think of a ULA as 1918 space, but you can also overlay public space on the same interface and easily go back and forth. One of the features that makes v6 better than v4. And I'm sorry I didn't have the right picture. I wanted to get a really cool v6 engine and just, do the transformation from v4 to v6, but couldn't get that done. Site local addressing has been deprecated. That was the predecessor to ULA. You can still use them if you were using them, but don't use them in new places. Makes sense? And finally, global unicast, which is everything else. I think I have it on there. Yeah. So, some references and an important feature. How do you tell a unicast address from an anycast address in v6? You can't. It's defined by the routing. And it's a little bit deep of a concept, so we're not going to hit it here. But you can have a unicast address that looks like an anycast address because it's the same thing. That's one of those mind twisters. Took me a while to wrap my head around it. Anycast doesn't actually exist in v4 land. It's kind of a ficton done with routing tricks. So you announce the same route from multiple places, and then your routing protocol will say, oh, you're the closest one. And that's why you set your resolver to quad 9, 8.8.8.8.8.8.8, 4422, or whatever that really simple one is that Cloud4 does. A little bit of a breather and a recap. You've seen 2001 DB832 used extensively. That is a prefix which is reserved for documentation. Just sort of like 192.0.2.0. And if you ever come across a mall where you're shopping at and you want to get on their Wi-Fi and they say enter an email address, well, jqpublic@example.com is a reserved domain which will never resolve to anywhere. It's reserved for documentation. Very few people actually check for example.com in their front-end parser. And just a little trick if you don't want to give your address away. Three fundamental differences. No broadcast. Packet fragmentation can only occur at the logical ends. If you were here for Paul Ebersman's DNS talk yesterday, was anybody here for that? Okay. So Paul was talking about why you can't globally filter ICMP for DNS because of packet sizes. Well, that's the reasons you can't fragment in the middle like you can with IPv4. Whatever goes in the wire has to come out of the wire, and PMTUD, PathMTU daemon, uses an ICMP command to say, hey guys, how big is my path? So that the ends can fragment if necessary. And there's a magic non-routable address called link local, which is wonderful and useful and non-routable. We'll see about that in a minute. So, breathe. And at this point, we're going to take 3 minutes if anybody has any direct questions. It's built into the schedule. Everybody's good? We can move on? Great. And variable. So, EUI64 is the basis and function. Now, everybody here is happy with CIDR address format. So you're used to having a /32 as one address. Well, in IPv6, /32 is a lot of space. And you want to be able to get there, and the way to get there on an Ethernet is by taking the Ethernet MAC address, which somebody has paid the IEEE a lot of money for the use of. And if they're intelligent, they don't have a 6 in their MAC address because we know what that breaks. If you are an MPLS person, know how having a 6 in your MAC breaks MPLS. There's a magic conversion. You take your MAC address, you split it down the middle, drop in a FFFE, which makes it a 64-bit number, and then you flip the 7th most significant bit from a 0 to a 1, which says, I am a local, not a universal address. And there's an example of it. And if you really want to go into the weeds on it, go to Wikipedia. Just Google for EUI64 transform and you'll get lots of examples. And a calculator, I found. There's a link to it in the end. So, if everybody's happy with that, and the /64 prefix, I'll now tell you a bit of magic. /64 is a magic number in IPv6 land. Don't ever let anybody tell you that you don't need a /64 of address space. It's built into the protocol. There's lots of them. So, link local. You can talk directly to your Ethernet neighbors using a link local address. Without any resolution, you can just say, I want to talk to link local FE, and you'll be able to get to it. Really cool for things like local printers, connecting to any local device. It just advertises its MAC address, and magically you're there if you happen to know what it is. We have this in the table, and you just concatenate it with the EUI64. There's your link local address. It's a well-known format. So if you know the MAC address of the interface that you're talking to, you can convert that into an EUI64 in one transform, and then concatenate it with FE80::, and you have your link local address. This, by the way, is a case where the : token is fixed, and everything after that you just suppress zeros in line. And there's your link local address. And as you see, the FFFE is in the middle. The 020 Charlie are in there. The second 0 Charlie is in there. And that is a properly formatted V6 address, complete with the CIDR block. Very useful, even if you can't globally route it. Please don't try to globally route it. Filter it. Filter it at every place you can possibly filter it. Okay, prefix length. Everybody's comfortable with CIDR, right? Can I see a show of hands? Everybody's comfortable with CIDR? Oh, good. Everybody like to drink cider? Slightly different kind? Yeah, good. The important thing to remember is that the smaller the number in the CIDR, the larger the block. So if you have a 2001 DB8::/32, that's a whole lot bigger than a 2001 DB8::/48. So we're going to build upwards. 48 is important. Even though a 48 is a huge amount of space, It's kind of like a 250, it's kind of like a /24 in v4 land. What's the smallest block you can inject into the public IPv4 routing tables? Anybody? /24, right. /48 is the smallest block you can inject into the public IPv6 tables. And for people who are doing routed anycast, /40 is what you have to do for your routed anycast. So if you look at the public v6 servers, they're 48s. 32 is your default allocation for an ISP. We're in the United States. We're all ISPs here for the most part. So /32 is what Aaron will give you. RIPE will also give you a 32 as your initial delegation. Other RIRs do different things for ISPs. The rules are entirely different for end users. And there's a link in the, whatever that thing is at the end, that has the Aaron rules in it. So you can go directly to that. And how many people here aren't ISPs? That should be a smaller number. Okay, 2. Does everybody assign a /48 for every customer? Good. You think about the fact that a /48 is the amount of subnets that a /16 is of individual IPv4 addresses. Starting to get a feel for the size of this? So why cheap out later? And all the public addresses assigned so far in 2000/3, which is something like 2 to the 125th of addresses. Okay, here we go. So, look backwards now. A 48 is the smallest block you can inject. That's the smallest block you should give every customer. Now, sometimes you'll use a 56 or a 60 for an individual customer that, for whatever reason, isn't getting directly injected into the public tables. If you're directly connecting someone in a data center to a top-of-rack switch, perhaps, you would give them a 56 or a 60. /64 is the normal LAN allocation. You don't actually want to go to anything shorter than a 64 for normal purposes because, as somebody who's a lot smarter than I am told me recently, the Broadcom Trident chipset, which is one of the basic building blocks of chipsets, is actually hardware optimized to switch on /64s. I don't know how true that is, but considering the pedigree of the guy who told me, I trust him. He's one of the chief architects of one of the switch companies. There are 64,000 of them in a /48. So you can just afford to give people a /64. As a matter of fact, you can afford to assign a /64 to each host, if you were so inclined. Well, that's actually a cool thing to do because you can have multiple unique unicast addresses assigned to each physical interface on each host. So you may as well give them some elbow room. Everybody cool with the concept? Great. We'll talk about why in a bit. Point to points. There's an RFC. Oh, I thought I had my notes. I guess I don't. Anyway, there's an RFC that says you should use a /64 as your basic VLAN or your basic host, and a /127 as your basic point-to-point. I can't think of any modern implementation of v6 that doesn't support 127s. A lot of ISPs will give you a 126 for your IPv6 point-to-point. That's a legacy of their provisioning system. And so you'll still see a lot of ISPs that do that. Ask your ISP for 127. It's the right thing to do. And they really shouldn't dense pack them inside of a single /64 because who knows what they'll break in the future. Loopback, 128. Okay, how many people here have the shirt that says 127001, there's no place like home? 1, 2, okay. You admit it? Do you have ::? Do you have : 1, there's no place like home? Well, ::1 is your local loopback. And there's no place like home. So, okay. If I timed this right, about 15 minutes ago, I told you about that curveball, no ARPs, because there's no broadcast. Has anybody here actually looked at a Wireshark trace of an ARP? Okay, it's really that simple. It's one packet that says, I am who has, and the other packet coming back saying, yep, I've got it, you can talk to me now. V6 is a little bit more complex than that. It's a new mechanism, it's a layer 3 mechanism called neighbor discovery. And with neighbor discovery, we get its humble servants. And the parameter discovery at the bottom, which is your link MTU and your hop limits, which are very important because if you don't know what your link MTU is, then you're going to either send something too big, there's a minimum 1280, and if you block ICMP, then you'll never get that it's too big message coming back. So don't block ICMP capriciously. V6 really needs it. You have to change your mindset with your firewalling. Okay. It's a directed multicast. Yeah, I'm not going to read it. It's there. It's what it is. And there are 3 pieces. Neighbor solicitation and duplicate address detection. One of the interesting things about V6 is that you can automatically configure. So really one of the first things you do in your neighbor detection is you go out and say, does anybody else have this duplicate already? Again, I'm not going into the weeds. Look on Wikipedia, there's a really good description of it. Router solicitations, IPv6 routers say, I'm here every 3 minutes, gives you the 64 prefixes, come to you, etc., and whether it's a default router. Again, I'm going back and harping on that /64 because that's your basic building block of V6. If you're giving somebody a /127 point-to-point, it'll know the fact that it's point-to-point by the fact that it's 127. If you've given somebody 126, yeah, it'll also know it's a point-to-point by the fact that it's a 126 because you've just got your broadcasts on the other side. Same as the /30. Well, except for the fact that there's actually a denial of service attack you can do against those 2 broadcasts in V6. That's why 127 is a better choice. So, once you've received an RA, you can magically auto-configure yourself. And some danger lurks, and we'll touch on that in a bit. And router solicitations are multicast. So, as I said, you are all the multicast domain, so I'm going to send my router solicitation, and it'll hit everybody, and hopefully one of you is going to come back and send me a router advertisement off-cycle. And you can redirect to a better router because being a very simple advertising protocol, I can then say, I'm your router, and then somebody come along later and say, I'm a better router. Okay. So, addressing. 1, statics. Everybody's happy with statics, right? Great. You can let the client take its router advertisement, take its EUI64, put the 2 of them together, and you'll get what's called SLAC, a stateless address, automatically generated. Is that nifty? I mean, really, is that nifty? How much configuration does it take to do V6 on a machine? You plug it in, you turn it on. As long as V6 is in your kernel, you're good to go. IT guys are paranoid and hate this. This is why IT guys, or girls, or small furry critters from Aldebaran 7, will turn off IPv6 every chance they get. because they're scared and they don't know how to deal with it. And third way, v6 DHCP, which is what lets your IT guys who are scared of stateless auto configuration be less scared. Okay. Cool thing that DHCP v6 does is you can say with DHCP v6, hey, I'm a subnet. Tell me what my subnet range is. And it'll give you a prefix. Nifty? Even better, you can ask it for bigger than a 64 using something called a PD hint. So you can go back and say, can I have a /60? Can I have a /56? And if the DHCP server is configured to do it, it'll give you that block, which you can then slice and dice locally. My personal provider, if I ask for a /60, will hand me a /60. Yeah, break it up in your house, firewall it however you want, put your media streamers on one subnet, put your IoT light bulbs on another subnet. Okay, you may have to run an IPv4 gateway at the end, but then you've got security at least. And a combination of using DHCP v6 PD and Slack is probably the most common home configuration. And in fact, that's the default for every consumer SOHO gateway I've looked at that supports v6. It'll do a DHCP PD for its subnet, and then it'll Slack locally, and it will usually Slack for its address. So Slack is really simple. You determine your MAC, get your UI64, get the covering Ethernet segment, slam them together, and you're done. Are you a vegetarian? Are you having trouble with this address? Because dead beef is indeed a legitimate IPv6 address. Because they're hex, which means you can actually have some fun embedding. If you want to, you can actually embed codes into your subnet addresses. And this also gives us our link local address. It's the same thing. Okay. I'm glad you're laughing. You were meant to. Okay, potential dangers of Slack. What are they? Well, I went back about IT guys and their paranoia. And before I insult anybody, is anybody here a paranoid IT person who turns off v6? What? You said again. Can you go up to a microphone and say that?
Yeah, sorry. Victor, Workday. Yeah, pretty much any big enterprise. You go there, you check your middle boxes, security guys will tell you IPv6, non-existent. Really simple story. It's just like that easy. The support of that protocol in boxes like IDP, all of your perimeter support, IPv6 is really, really like shallow there. Software support IPv6. Hadoop, open source, IPv6 is not supported, 2020.
Yeah, that's the problem. Because people are scared of IPv6, and actually I would say most of the major sniffers and a lot of your SEM boxes now actually grok v6 properly. And I know at least Apple and Microsoft are very v6-centric at this point. If you're going to develop it for either of them, it's going to speak v6. But you can speak v6 without knowing it. And that's, for some people, a problem. Well, you can either turn it off in the kernel, or you can get with it and go forward. Okay. Real problem in some parts of the world, a v6 address done by Slack is attached to the device. It's burned in. There are some regimes that if they want to track you, will track your v6 addresses. So if you take your laptop and you go to Pete's Coffee and then you go to Tim Hortons and you run your v6 there, well, Bolshoi Bratz vidit was. Big Brother's watching you. And you can track somebody's movements by their v6 address. This is a very real concern in some places. There are privacy addressing which do rotations. The original ones you could actually walk backwards on. 8084 is the most recent RFC covering this. Truth is, though, unless you're a developer, don't worry about it. Because unless you're a developer putting it in the kernel, you can't do anything anyway. I believe Windows 10 does support it in the most recent. OS X, I've been told supports it since one release back, although I've not actually done a sniff to prove that, so don't take me at my word. And there is a gorilla. NAT. How many people here love NAT? One. You're having a true thing with it? You're so-so on NAT? Okay. Personally, I don't like NAT. But there are places where you actually want to do NAT in v6 land. You want to do NAT on the prefix. This is a really handy thing to do if you have two providers so you can easily switch out which week you're going out. You keep your host address the same and you change your prefix. The concept of actually natting an ipv6 host address is anathema to anybody in the v6 world. So it's not the same as local NAT and IPv4 land where you're just taking one and, oh, I've got 416 machines here, I will take 416 machines and map them out of one port and hope that your port mapping doesn't break on the way back. Use a good stateful firewall if you're providing inbound services, and a simple block if you don't. But ICMP is a requirement for it to work properly. Now, you see a three-letter word, which I call a four-letter word to be quite honest, in there. Peripheral interconnect. That's not so bad, is it? You plug the card in, and it works. Talks to the CPU. The latest spec gives you a lot of bandwidth. Wrong PCI. Okay. If anybody here can tell me where in 1.3.7 of the PCI spec it says, thou shalt NAT, and thou shalt not use IPv6, I will buy you a beer. I will buy you any $16 beer at that bar. And I'll use $2 bills to do it with. That's how obscure I'll be. But the truth of the matter is, all it says is that you have to obscure your internal network and don't show your outside. Don't show your inside addresses to the outside. Load balancing, proper stateful firewalls. This is PCI consultants who don't understand networking. Yes, that was a soapbox. I'm standing on it. And if anybody wants to discuss that afterwards, I'll be happy to. Now, I've been harping on the fact that a /64 is the basic building block. Well, a long time ago, people would assign a 124 or 122 or some smaller block. Well, sometimes they do this simply out of the misguidance that, hey, 124 is 255 host addresses. That's a /24's worth. That's all you need. Sometimes they would do it out of fear of a denial of service attack with network discovery, where you could simply keep poking MAC addresses and fill the tables on a switch. That was true maybe 10 years ago. Now, it's been fixed in hardware on all modern top-of-rack switches. All of the later versions, iOS XR has fixed it. Juno's fixed it in 13. There's no issue with the /64 at the edge. And I have taken an Ixia and tried to break various bits of hardware and haven't been able to. So don't do it. Because your switch will switch faster with 64s. This is my breather. Have a chart. Sorry. Okay. So differences. 32 bits, 128 bits. You can take all of your V4 address space and just map your physical address representation into a V6 address. Address types, unicast, multicast, broadcast, unicast, multicast, anycast. Your packet header sizes are different. V6 is bigger. Get over it. It'll get even bigger if you're using segment routing. And if you embed segment routing and say you're doing VXLAN and then you want to stack that into so you've got your UDP header, your segment routing headers, your VXLAN header, and then your payload, jumbo frames are your friend. But this is also why the 1280 byte minimum MTU. IPsec is baked into IPv6 even if you don't use it. It's an add-on in v4. So, time for a quick mindset change. Who here is a router jockey? 1, 2, 3, 4, 5, 6, 7. Good. 8, 9, 10. How many of you use EIGRP? Dodge that bullet. Okay, some realities. What? Yeah, this is why there are standards. Okay, realities. The RIRs are functionally out of v6 space. Yeah, there's the secondary market. I would really like to put those guys out of business with v6. It's functionally unlimited, you can get it. Use a proper hierarchy. There's no reason to conserve v6 space. If you run out of your /32, get more. If you run out of more, and by the way, I know Aaron actually pads their allocations so that if you ask for more, they can just say, okay, here's your next block, and it's just contiguous space. Other RIRs do similar things, but we're in North America, so I'll reference Aaron. Use a proper hierarchy. You have a /32, give each of your pops a /36, and then give your super regions bigger blocks. So if you have a /32, you can comfortably have about 48 pops with enough space to populate the world a couple of times over. And that's before you get down to your end addressing. You may need to pass v4 over an IP6 link at some point. How many people in here are using v6 without realizing it? How many people in here have a modern cell phone that speaks LTE? You got it. That's all v6, which broke Skype, which is why you now had to NAT from v4 to v6 inside your phone so you could present a v4 address to Skype, which is why Apple got really hard-nosed about all of your apps have to speak v6 natively so they didn't have to do that translation. Cool, isn't it? So that's tunneling. And it's beyond the scope of this presentation. Jeff Houston of APNIC has done some really awesome research on tunneling and the effects of tunneling. Did I leave out huge amounts? Yeah, you bet. v6 just like v4, but it's just bigger, right? Well, not exactly. Statics are statics. 30, 31, 127. Easy peasy. Who's still using RIP? Anyone? Good. Next. OSPF2 doesn't speak v6. OSPF v3 does speak v6. Many people will actually run parallel stacks with OSPF v2 and OSPF v3 as opposed to running OSPF v3 with realms. There are some neat tricks you can play with that. You can have slightly different allocations. You can do different quality of service, whatever. I have found a few places that are doing v3 realms in production, mostly in Africa. I don't know. Point is, though, depending upon what routing protocols you're running, in order to run v6 effectively, you may have to throw out your current routing. Or you may have to run a parallel routing protocol to get v6. Personally, my choice is ISIS, because it doesn't care. v6, v4, v8, whatever, it'll run it, because it's actually running at a layer below layer 3. They're equal, they're transparent. BGP, well, BGP will do anything to anybody. I swear it was invented by Victorinox. It's the Swiss Army knife of routing protocols. You can do anything with it. Of course, you can also cut your toes off like you can with a Swiss Army knife. Be careful. It looks just like v4, v6. It's all in your filters. Cisco will let you pass v4 over v6, v6 over v4 connection. Juniper will let you pass v4 routing information over a v6 connection, which is kind of cool that they started doing that in 16.2. I don't know anybody who does that, by the way. You can get into religious arguments over whether you want to have multiple NLRI in one link. I'm not getting into that religious argument. Just, you can do it either way. Best common practice for providers is to give you 2 separate BGP sessions. Now, evil, pure and simple from the 8th dimension. Anybody who gets that gets a prize. Like I said, Jeff Houston did a presentation. Sometimes you need to pass stuff over the wrong protocol in tunnels. Maybe it's not so bad. It's close though. 464XLAT and NAT64 work really well, because in that case you're actually taking your v6, whacking your header, running it down, and pushing it back on. In NAT64 it's more complex. And there's a presentation at OSNOG next week if you want to go see that. Everybody go buy your tickets to Melbourne. I've seen Andrew Koo's doing a presentation on it. I've seen his documentation. It's a good talk. IPv4 and IPv6 have the same failure rate in native mode, and it's down around 0.2%. IPv6 tunneled over IPv4 in a 6-to-4 tunnel gives you about a 2% connection failure rate. With happy eyeballs, this can make a difference and can give you unhappy customers. So if your DNS is set up properly to return an A record, it will do the right thing. Somebody coming in from a tunnel gets the quad A record coming back at them, tries to do an IPv6, fails, happy eyeballs will save it. Anybody here know what happy eyeballs is? Okay. It's a means of saying, quickly timing out your v6 connection and falling back to v4. You get both you get the quad A and the A record back, you try the quad A record first, you can't make your connection, you give it a amount of time, you fall back. And that's about it. I'm on time. If you're embedding a v6 address into a URL, embed it in square brackets. That's going to throw a lot of people the first time they see v6 and they just try to put it in there. That'll be interpreted as a logical address. Embed it in square brackets does the right thing. Square bracket, colon, port number. Ping and trace route and a lot of other utilities will default to v4. If they get a quad A and a single A record back, they'll default to v4. So you have to tell it or give it a literal address. And it's ping 6 or ping-6 or some variant based on your operating system. Q&A footnotes. Space, it's really big. You got that one. Aston Martin never released the DB8. It would have come out in 2001. But the DB9, the successor to the DB7 was the DB9 because Aston Martin didn't want to be known for putting a V8 into a car that came out with a V12. Okay. The Ebel, obviously Buckaroo Banzai was reputed to have said that at a press conference. As far as you know, he's still practicing medicine and doing particle physics in New Jersey. The rest of the links, and there is an appendix with a bunch of router configurations, which I'm just going to page through. They're all in the slides you can download. Thank you. Questions? We're on time. Please go to a microphone. Tell us who you are and who you're talking for, if you're talking to yourself. And before you do that, I'll say, that's a coup, and he's the one giving the presentation on tunneling and V6 at OSNOG. Your timing was perfect, Andrew. Your question, please, sir.
Nate Todd with Viasat Communications. A quick question in regards, twofold. You had mentioned for point-to-point and then just straight loopback address suggestions. What would you do to handle like a point-to-multipoint where I've got maybe 3 or 4 routers in the same domain? Would that just automatically be a /64?
That would automatically be a /64.
Okay. Second question in regards to the smallest prefix publicly acceptable on the internet for peering. Is the 48 globally adopted, or is that something just Aaron?
That's globally adopted.
Okay. Well, the reason I ask is because we're getting /64s from our LACMIC peering down in Brazil. So I didn't know if it was something that's.
In rub space, there's 6 now. It's a lot of connected space, a lot of rub space, that's small.
Okay, everybody I know filters on 48s. So, and in RIPE. Yeah. Anyway, next, please.
Dave Krause, Siena. I have a question more from a personal point, and that is it possible to just get an allocation of IP6 addresses for myself, like a phone number?
Sure. Go to your RIR and say, I want a /48, and they'll say, give me $500.
Okay.
There is a small movement afoot to start the mechanism in PPML to basically tell the RIRs to basically generate a PEZ dispenser for /48s, swipe your credit card, get a 48. That's a couple years off at the earliest, because people are just starting to think about it in the bar.
Thanks.
But Alex, the other thing is that if you get this small allocation, it comes with a free AS number.
Comes with a free AS number?
Yes.
All right.
Yeah. Next, please.
Sure. Hey, Jason Bodie, Moody's. Great talk.
Thank you.
Yeah, well done. I wanted to get your opinion and take on helping folks accelerate this wonderful protocol and getting it implemented. What are your thoughts around using 6VPE like RFC4659? And for those that aren't running ISIS, that have OSPF out there, but they want to get there and they're running an MPLS network?
For OSPF v3?
No, OSPF v2 and MPLS.
You can run OSPF v3. You can force, at least on Juniper, into RSVP.3 table, but yeah.
I'm checking on 6VPE, right, in general. So I don't know if you're familiar with it or.
I am familiar with it.
Okay.
In general, I don't like tunneling, and
Native.
yeah. But if you have to, 6RD,
Sure.
or just pop it into an MPLS tunnel.
Okay. Very good. Thanks.
Thank you. Next, please.
Chris Herbwood, Berkeley Lab. How much, you said ICMP is required?
Yes.
All ICMP or sometimes?
I was hand waving but there are about 9 ICMP types that you want to let through for V6 to work properly. And I really was going at a high level here. I'll take it offline with you later and send you the list if you want, if you give me your address. Anybody else? Okay, I'm feeling good. I only got hit by 3 tomatoes. Thank you very much. We are dead nuts on time. I will not stand between you and the break, which is waiting outside. Come back in about a half hour.